A pleasant afternoon po to everyone. I am Nemy Chavez Principe, and I will present my thesis entitled Reduction of Welding Porosity Rate in Manual Butt Joint Welding Process in a Boiler Manufacturing Company. Introduction. So the welding defects, porosity, lack of fusion, undercut, excess penetration, concavity, offset, filler, incomplete penetration, and tungsten inclusion.
Excuse me, Miss. Can you turn on your screen, please? Cannot see your presentation at all. Okay.
Okay.
It's fine now.
Excuse me. Sorry to interrupt. So, Miss Nemy, if the presentation has a problem, you can back to the not use the non-slideshow. That would be fine.
Okay.
It's,
we can see your instructions.
Okay.
So the welding defects, porosity, lack of fusion, undercut, excess penetration, concavity, offset, filler, incomplete penetration, and tungsten inclusion. So by using Lean Six Sigma technique, the defect was minimized and product excellence was confirmed. So the target weld porosity rate that needs to be reduced was 33%. So among the butt joint manual welding process, welding porosity rate has the maximum number of defects with defects per million opportunity of 68. So the research was carried out on application of Lean Six Sigma method in the manual welding process in a boiler manufacturing company to reduce porosity rate. So here are the objectives of the study. First, to define the current condition of welding defects. Then to measure the porosity of rate in terms of control chart of porosity, process capability analysis, and sigma level. And the third is to analyze the root causes of porosity rate using YY analysis, and to reduce the porosity rate by developing maintenance plan schedule, welder performance qualification process, and also control chart, process capability analysis, and so on. And the last is to recommend control plan to sustain the proposed improvement. So the method that I used is applied method of research. So applied research, this is used in order to find solutions to everyday problems and develop innovative technologies. So Lean Six Sigma method was being applied, in which the principle of define, measure, analyze, improve, and control was used as a roadmap. So I will go to results and discussion. So the first problem-solving methodology that is used in Six Sigma is define. So I use Minitab software and I constructed Pareto chart to know or to define the highest percentage of defects, welding defects in manual butt joint welding process. So the figure shows the Pareto chart in terms of defect in manual butt joint welding process. As you can see, porosity has the highest percentage. So the next is the process mapping. The figure shows the standard operating procedure or the sequence of steps of manual batch joint welding process. It is defined that the problem wherein the researchers concentrated in this is the manual batch joint welding method because the common defects occurred in this. So the manual batch joint welding process was selected wherein porosity has the highest percentage corresponding to 35.98%. So the next figure shows the project charter. This was used in order to summarize the findings of defined phase of the project. So in cooperation with the project team, the scope of the project concentrated on manual batch joint welding process. So the responsibilities of the team comprised of team leader, then internal and external members. So I'm the external member, and where calculation and justification of data essential for study. Next slide po. The next is the C chart. The next figure shows the C chart before improvement. And this is the measure problem. This is the measure pace. So it is a kind of control chart utilized in order to monitor the count kind data, usually whole quantity of non-conformities for components. So it shows the number of defects was stable and in control, though there was no point failed, but the target would rejection rate of 5% per manual welder that need to reduce was not in few weeks. The next is the process capability of defects before improvement. So in the summary of statistics table, the target 5% showed the maximum allowable percent defective for the process. So the percent defective estimated was 0.89%, which was below the maximum allowable percent defective. So the upper control limit for percent defective was 1.21%. So it was less than the maximum allowable percent defective value. So there was 95% confidence that the process was capable and met the specifications, but took into account the variability from random sampling that affected the estimate. The next figure is shows the process sigma before improvement. So from the resulting defects per million opportunity of the porosity defect shown in the figure, it created 68 defects per million opportunities. And the sigma level of porosity defects current situation was 4.57. So since the quantity of defects per million opportunity falls in this category. So the next is the analyze phase, wherein I use the YY analysis. As you can see, in the conclusion part, now the true cause when I analyze the problem, so there is no PM schedule, and the last data were 2 years ago. The other is hired welders have no formal certification, and there is no supplier selection specification. So the next is, the next shows the screening design. So this tabulates the objective of the experiment, that was to minimize the porosity identified variables where current, voltage, and travel with low and high setting indication. So full factor design of experiment with 3 variables was used, resulting to 8 runs. Then the next shows the low and high setting of 3 factors. This was run by using JMP software. By JMP statistical software with randomization. So porosity was left blank, as it will be filled with count of porosity after running each combinations of either low or high setting in each variable. So positive means that the variable has to set high, while means that the variable has to set low. Then the next is a list of p-value. So a law of p-value shows that the result was statistically significant. So there were 2 p-values that were below 0.05 of variables, such as current and the voltage. So there was a strong relationship between current, voltage, and with porosity. So the next is the about the maintenance plan schedule. So the planned or scheduled maintenance is a list of predetermined maintenance actions carried out at regular time intervals that are aimed at the prevention of breakdowns. Then the next shows the details of the performance qualification processes initiated to take quality development in welder skill area. So this procedure explains the ways on how to develop the capability of welder to accomplish acceptable welds and the best performance of welder selected to execute welding on a precise project. So this is the constructed Pareto chart of defects after improvement. And also the C chart. The next is the C chart, the process capability of defects after improvement. And also the process sigma. Then the next is the project control plan under control phase. So this shows the improved Six Sigma project control plan for welding process to make sure that the constant and to efficiently apply the control measures. Then this is my conclusion. So the highest number of defects is the welding porosity defect. The C chart after improvement shows that the number of defects was stable and in control. Then the porosity was mainly caused by no preventive maintenance schedule. So a conduct design of experiment, and then the researcher was able to develop a maintenance plan schedule to reduce the porosity rate. And it was also able to, the researcher was also able to recommend control plan to sustain the proposed
ของ
improvement.
ผมคนสุดท้ายครับ
So these are my references.
ได้ครับขอบคุณครับ
That's all. Thank you po.
ฮัลโหล
Okay.
งอนผมอยู่
Any of you on the community
ไม่
have
รู้
any?
ว่าที่ผมว่าผมไม่ได้เข้าไปจะ
Let me ask you, what technique do they use for welding? They use some kind of inert gas fumigation welding, or they just use the regular welding equipment? Hello.
Hello po.
What kind of device you use for the welding? Just regular, just plain welding device, or some kind of specialized device like argon fumigation welding, or just plain welding? I don't know. You know what I mean?
Can you repeat po your question po? Pardon po.
Maybe it's I don't know. And any question from the floor, or any of you were here? Later, that's my fellow gone. Okay. I don't have your paper, and I cannot track your presentation well, because maybe I don't have the concentration enough, so I don't have any more questions, unless anyone else does. No? So thank you. Oh, you have question? Dr. Papon, you have question on her?
I have no questions. I expect someone would raise some questions here. I think I asked too many already in these sessions. Anyone who have questions once more time? No? Okay, then we move on to the next one.
Okay, good. Thank you, Dr. Papon. Thank you, Nemy. Thank you very much for being with us. And